This is section 112. We're going to take a look at interval notation. So in this video, we're going to write a set of real numbers in interval notation. Now remember, anything that's blue, you need to write it down. Examples are included as blue. If it's gold, you need a flashcard and memorize it. These are essential math concepts, but you also need to write it down. So as a reminder, in the last video, we defined a set as a well-defined collection of objects, which are called elements of that set. And it has to be well-defined. There can't be ambiguity, there can't be opinions involved, otherwise it doesn't make it a set. And we said we had the three different ways to define a set. Verbally, we just write a sentence. The roster method, which is where we list each element, and it's easier to use a roster method when we have elements to list. And then we have that set builder method, where we have a dummy variable, and then we say what that dummy variable is or isn't. So in the sets of numbers, basically the way that you can think of interval notation is how we express these inequalities. We are going to convert it into interval notation. Now, long story short, inequalities is a very inefficient way to express a range of numbers or a whole bunch of numbers between two numbers. Using the word range is probably not a right word because the range actually means something else in math. So far we're going to focus on the real numbers, and essentially we're going to get segments of lines. Now the problem is when we have a line segment, no matter where we start, let's just say here at A and we end here at B, there is technically an infinite number of values in between. Now do we want to write those infinite numbers out? No. So what we do is we use notation to define where it starts and where it ends. Now the question is, where it starts, do we include or exclude the value? If we want to include the value, we use these brackets. Now another way of thinking of it is if it was like a closed circle. So if you remember when it says equal to for an inequality, it means closed circle. That's going to be the same thing as a bracket. Now if it was an open circle, we are going to use parentheses, and the same goes for infinity. And infinity just means it goes on forever either in the negative direction or goes on forever in the positive direction. Now another way of thinking about parentheses is parentheses essentially means like not definable. So we can't define it. We don't know what it actually is. And so we can say we can get as close to that number as possible, but we actually can't include the number, or we don't know what that number is. And so like in this instance, infinity, it's not definable, because the moment that you say infinity is this really, really big number, I'm just going to add 1 to it and prove you wrong. So open circle or infinity is going to be parentheses. A closed circle, closed dot, that's going to be brackets. So let's look at a few examples here, and we're going to take a look at a few others. So I'm looking at this. This is going to be the set builder. And so I defined it as like my variable, my dummy variable is x. And I'm saying x is between these two numbers here. Well, I'm looking at the fact that that says less than or equal to. So that means I need to include the number. So that's why that's going to have a bracket. And that doesn't have an equal to, so I know that this is going to be a parenthesis. And so if I wanted to draw it, it's going to be a closed circle at 1, and it's going to go all the way to 3 with an open circle. Same thing here. I know it's going to be a closed circle and a closed circle, or a bracket and a bracket. Starts at -1, ends at 4. Now this one is saying everything less than or equal to 5. So that means that the 5 itself is going to have a bracket, but it's everything less than that, and it goes on forever, and so that's why it's going to be negative infinity. Well, negative infinity, we just express as an arrow going forever in the negative direction. So it's kind of I know we kind of are going around with these. Let's kind of look at a couple examples and put those together. So we have our set builder method. We're defining x, and we're just saying x is everything, and then I listed an exclusion, but x cannot be 3. So the way that we do this is we always need to visualize it. So it's kind of hard to visualize. Okay, what does that mean? So here's my number line. And here's 0, here's 1, here's 2, here's 3, 4, etc., etc. Now we're saying it can't equal 3. So I'm going to put a big, giant open circle there. I'm just saying the open circle means it's not defined. It can't define it there. I'm going to put my open circle. But I never said it can't be anything else. So I'm going to shade everything else. So translating this arrow, it's going down forever, and this arrow, it's going up forever. Well, this first interval is going to be negative infinity since it's going down forever, and it's going to go all the way, and it's going to stop here at 3. And then, because it's an open circle, we're going to use a parenthesis. Now I'm going to change the color because it'll be a little easier to see. Now I have another set here. Now that set starts at 3, parenthesis, because it's an open circle, and it's going to go on to infinity. It's going to go forever that way. Now, how do I say that these are together? Because we know that they're all in the same number line. That means they're together. We're going to use this symbol, U, union. It's like this giant U, and it means union, and it just means that the sets are together. We're going to talk a little bit more about union tomorrow. Let's look at the next one. This one, we're saying x can't equal positive 3 or negative 3. So let's visualize it again. I defined x is everything, and I said some exceptions. It can't be positive 3, it can't be negative 3. So here's negative 3. Here's positive 3. 0 is obviously in the middle, negative 1, negative 2, positive 1, positive 2. So we have all our values there. But I said x is everything. It just can't be those two numbers. So shade everything else. So I have here 3 intervals. I have an interval that goes on forever in the negative direction. I have an interval that's in between here. And I have an interval that goes on forever in that direction. So I should have 3 intervals. So the first one, starting in the lowest number, so negative infinity, it's going to go to negative 3, parenthesis, because it's an open circle. Now I have this interval here. So that's from negative 3, and it stops here at positive 3, parenthesis, because it's an open circle. And then I have this interval from 0 to infinity, so 3 to positive infinity. Now how do I say that these are together? We use the union symbol. And this is our answer. So what did we learn today? We wrote a set of real numbers in interval notation. And just to kind of replay it from the previous example here, we took this set builder method and we wrote the interval notation equivalent of that. So this does conclude our lesson. If you have any other questions, please leave them in the comments.